says. Now convert a number, see the question 123 the base 10, so it is a decimal number, to octal, binary, hexadecimal. So now they gave a number, decimal number, now we have to convert into an octal number, binary number and hexadecimal number. So these three things we have seen now only. So how to do that? 123, if we want a binary value, divided it by 2 and write down the remainder on the right side. So 61 2s are 122 and the remainder is 1, and again divided by 2, and 30 2s are 60, remainder 1, 15 2s are 30, remainder 0, and 7 2s are 14, 1, and 3 2s are 6, and then remainder 1, 1 2s are 2. So now you write from bottom to top, okay, from bottom to top, okay, that is 1 1 1 1 0 1 1. Okay, so this is the equivalent binary value for this decimal number. In the same way, if we want to get an octal value for this 123 divided by octal, so divided by 8, so 15 8s are 120, remainder 3, and 1 8s are 8, remainder 7. You can use another step also, or you can leave it as this also. 0 8s are 0, and then now you can write 1 here, 1 7 3. Or if it is less than 8, we can leave it as it is also. So 173 is its octal value, and for 123's equivalent hexadecimal is divided it by 16. So 17 16s are 12, right? So the remainder is 11. So 11 is the equivalent value for 11 in Hexa is B. So A for 10 and for B for 11. So what is the answer is 7BH. So this is converting the decimal value to its equivalent octal value, binary value and hexadecimal value. So now we have to convert from in a reverse wise. Now we have to convert this into octal to decimal, binary to decimal and hexadecimal to decimal. So that conversion we are going to see now. So, okay, rules for conversion from binary to decimal. So rules for, we are getting this binary value now, this binary value. So now how to convert this binary value into decimal value. Okay. So rules for conversion from binary to decimal is, first one, write the digits of the binary number. So this is the binary number 1 0 1 0 1. And then write down the binary number and list the powers of 2. So we have to list out the powers of 2. 2 power 0, 2 power 1, 2 power 2, 2 power 3. You have to write down this list of powers of 2 from right to left. Right to left. Okay. So first you have to write this 1 and this 1 into 2 power 0. And then the next one is 0 into 2 power 1 and 1 into 2 power 2. 0 into 2 power 3, 1 into 2 power 4. Now you can say 2 to the power of 0 is 1. So 1 into 1, 1. 0 into any number, 0. So whenever you see 0, no, you can make it as 0 here. Okay, no need to calculate other things. So 2 2s are 4 and 4 into 1 is 4 and 2 to the power of 4 is 16. So write down the 16 here. 16 plus 4, 20, 20 plus 1, 21. That's it. So the equivalent binary value for decimal is this. So 10101, this equivalent, this is a binary value. So the equivalent decimal value for this binary number is 21. Okay, understood? So write down the digits, write down the binary number and list the powers of 2 from right to left and multiply the digits in the binary number. Okay, multiply the digits. Okay, these are all the digits in the binary number into with the corresponding powers of 2 and then add all to get the final values. Once again I will tell, write down the digits of the binary number. Second step, write down the binary number and the list of powers of 2 from right to left. From right to left. Okay. This is 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3 and 2 to the power 4. Then multiply the digit, this digit, okay, this digit into its equivalent corresponding powers of 2 and then add all to get the final value. So 21 is the final value. Okay. The next one is the rules for conversion from octal to decimal. Octal to decimal. So the same way we have to do it. Previously how we did is we have written this binary power. Okay. Binary list of powers of 2. So now we have to write the power of 8. Rules for conversion from octal to decimal. So now we are going to do, this is an octal value 37246. So convert the octal number to decimal value. So write down the octal number, write the powers of 8 from right to left. The same thing here we used 2. In this place we are going to use the power of 8. Multiply the digit in the octal number with the corresponding powers of 8. See? So this is the octal value 37246. This is 8 to the power 0. This is 8 to the power 1, 8 to the power 2, 8 to the power 3, 8 to the power 4. 8 zeros are 1, 1 6 are 6, 8 8 4s are 32, 16 2s are 64 2s are 128. So same way we are getting 8 to the power 3, 8 to the power 4. Okay, and then add all the values. So this is its equivalent decimal value. This one is equivalent octal value. And the next conversion is the rules for conversion from octal to decimal. Okay. So what we have seen, octal to decimal. So the same, another example, we can also write it like this. Write the digits in the octal number, write the powers of 8 base. Okay, so 2 into this number into 8 to the power 0, and this is a second example for octal conversion. Okay, so 7 into 8 to the power 1, this is 1 into 8 to the power 2. So the remainder is 1 2 2. Okay, write the digits in the octal number, write the powers of 8 from right to left. Okay, this is power. Okay, we have to write the powers 8 power 0, 8 power 1 and 8 power 2. So multiply this digit into its equivalent power. Okay, the octal number with the corresponding power of 8. Okay, multiply it and add. See, 8 to the power of 0 1, 1 2s are 2, and 8 7s are 56, 8 square 64 into 1 64. So now you have to add all the values, that is 122 is the equivalent decimal value for that octal. Now the rules for conversion from hexa to decimal. So we have seen how to convert from binary to decimal, octal to decimal. So now we are going to see rules for conversion from hexa to decimal. Okay, so whatever the rules applied, the same thing. Okay, write the digit of the hexa number. So this is an hexa number. They have given hexa number 1A, the base 16. So this is the hexa number. Write the powers of 16 base from right to left. From right to left. So this is 16 to the power of 0 and 16 to the power of 1. Write down the equivalent powers of 16 from right to left. Okay, multiply the digit in the hexa number with the corresponding power of 16. So I have to multiply. What's the value for A in hexadecimal is, A is 10. So 10 into 16 to the power of 0, that is 16 power to 0 is 1. 1 tens are 10. So 1 into 16 is 16. So now we have to add these values. So whatever we have seen previously, the same concept. Okay, multiply the digit in the hexa number and the corresponding powers of 16. Add all to get the final values. Add all to get the final value is 26. Okay, write the digits of the hexa number, write the powers of 16 from right to left, multiply the digit in the hexa number and the corresponding powers of 16. Add all to get the final values. So this is the rules for converting from hexa number into decimal value. Okay, so once again I will see the glance. Okay, so rules for converting binary to decimal. Binary to decimal, you have to take a number, then multiply it by to the power of base to the power of 2. Multiply the digits and add all to get the final values. So same thing, rules for conversion from octal to decimal. Take the digital octal number and then write the powers of 8. Here 8/0, 8/1, 8. See here 2/0, 2/1, 2/2. We have to multiply with each digit. Here what we did is to the 8 to the power of 0, 8 to the power of 1, 8 to the power of 2, 8 to the power of 3. So we are using octal base. So in the same way, in the next session we are using hexa 16 base. Write the digit, write the power of 16 from right to left, multiply the digit in the hexa number and with the corresponding power of base. Okay, add all the values to get the final values. Okay, and then they will ask like this. Okay, 173 is an octal value. How to convert this into a decimal? So to convert from octal to decimal, what we have to take the number. Okay, take this number 371 and which should be multiplied with to the power of 8. So because this is octal value, so to convert this into decimal, so multiply it, then the answer is 123. So in the same way, this is a binary value. They will ask questions like this. Okay, so 41011, this is a binary value. How to convert this binary value into decimal value? So take down this number and multiply it by to the power of 2. 2 to the power 0, 2 to the power 1, 2 to the power 2. Okay, this is 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5. This is 2. So multiply with this number into its equivalent to the power of the space. Then add all the values, right? Add all the values. So you will get its equivalent decimal value. So similarly here you can see 7BH. This is an hexadecimal value. This is an hexadecimal value. How to convert this into an decimal value? So how will you get it? So 7B 11. Okay, 7B means what? A is 10. In an hexadecimal, A is 10 and B is 11 and C is 12 and D is 13. E is 14, right? F is 15. So for B I am written as 11. So 11 into this is 16 power 0 and this is 16 power 1. So 11 into 16 power 0, 7 into 16 power 1. So if you multiply this, you will get 11 here, and then 7 into 16, 112. So the total is 123. So 123 is its equivalent decimal value. So you see, so my conversions all are correct. So from octal to decimal 123, binary to and binary to decimal 123 and hexa to 123. So because I taken only 123 for various conversion, okay, you will get all in all the conversion and the same value.